Hello, chemistry students. Today we will be continuing our qualitative analysis experiment with the hydrogen sulfide group in basic conditions, also known as the ammonium sulfide group or group 3. The ions we will be testing for in this group are zinc, nickel 2, iron 3, manganese 2, aluminum, and chromium. Let's get started. We will begin this procedure with a test solution containing zinc, nickel 2, iron 3, manganese 2, aluminum, and chromium ions. We could also begin this procedure with the S3 or S3A solution from the hydrogen sulfide group or group 2. To begin, we will add 1 milliliter of 3 molar ammonium chloride to our test solution. We will then neutralize the mixture with the addition of 6 molar ammonia. After neutralization, we will add 0.5 milliliters in excess of 6 molar ammonia to our test solution. The resulting flocculate indicates the presence of hydroxide with iron 3, aluminum 3, and chromium 3. Without centrifuging, we're going to saturate our solution with hydrogen sulfide by adding 10 to 12 drops of 1 molar thioacetamide. We will stir our mixture well and then heat the mixture in a hot water bath for 5 minutes. After heating for 5 minutes, we will add an additional 0.5 milliliters of 6 molar ammonia, stir the mixture well, warm the mixture slightly, and then centrifuge the mixture. This is what our mixture looks like after centrifugation. If we were going to move on and analyze the group 4 carbonates, we would need to decant our solution into a new test tube labeled S9. We would then need to acidify our solution with hydrochloric acid and heat the solution in a hot water bath for 5 minutes. However, we will not be analyzing for the group 4 carbonates, so we can dispose of our solution in a waste container. We will save the residue, which will be relabeled as residue R9. We have relabeled our residue as residue R9. We will now wash residue R9 with 1 milliliter of deionized water, 2 drops of 6 molar ammonia, and 2 drops of 3 molar ammonium chloride. We will then centrifuge and discard the wash. It is important not to let residue R9 dry. We will now separate zinc sulfide and nickel sulfide. To residue R9, we're going to add 2 milliliters of 1 molar sodium sulfate. We will then add 2 milliliters of 1 molar sodium bisulfate. We will stir the mixture for 1 minute and then centrifuge. This is what our test tube looks like after centrifugation. The dark precipitate indicates the presence of zinc and nickel. We will decant the solution into a new test tube labeled S10 for solution S10. We will heat solution S10 in a boiling water bath for at least 10 minutes to remove all hydrogen sulfide gas. After 10 minutes, we will remove the test tube from the heat and allow it to cool. We will save solution S10 for the analysis of iron, manganese, aluminum, and chromium ions. We have relabeled our residue containing zinc and nickel as residue R10. We will now perform the test for zinc ion. To begin, we will wash residue R10 with 5 milliliters of deionized water and 2 drops of 3 molar ammonium chloride. We will then mix, centrifuge, and discard the wash. We will next add 1 milliliter of deionized water and 2 drops of 6 molar hydrochloric acid to residue R10. We will stir for 1 minute and centrifuge. This is what our mixture looks like after centrifugation. We will now decant the solution into a new test tube labeled S11. We will save the residue for analysis of nickel and relabel the residue as residue R11. To solution S11, we will add 1 drop of 1 molar thioacetamide and 1 drop of 6 molar sodium hydroxide. We will then place in a hot water bath and heat for 5 minutes. This produces sodium hydrosulfide, which ensures sufficient sulfide ion. After 5 minutes of heating, we will remove solution S11 from the heat and add 10 drops of 3 molar ammonium acetate. We will stir, centrifuge, and discard the wash liquid. This light gray precipitate of zinc sulfide indicates the presence of zinc ion. To our light gray precipitate, we will add 10 drops of deionized water and then add 6 molar hydrochloric acid dropwise with stirring until the mixture is just acidic. This is what our mixture looks like after centrifugation. We will then decant the clear solution into a new test tube. To our clear solution, we will add 10 to 20 drops of 0.1 molar potassium ferrocyanide and stir well. We then need to centrifuge our mixture. This is what our mixture looks like after centrifugation. We'll next discard the solution and attempt to dissolve the precipitate with 12 drops of 6 molar sodium hydroxide. We'll stir the mixture thoroughly while heating in a hot water bath. Our precipitate has completely dissolved, and this confirms the presence of zinc ion. We will now perform the test for nickel 2 ion. We'll add 2 drops of 6 molar nitric acid to residue R11, and then we'll heat in a hot water bath to dissolve the sulfides and evaporate the solution to 1 drop. After evaporating our solution down to 1 drop, we will add 1 milliliter of deionized water. We'll then centrifuge our mixture to separate the solution from the remaining dark-colored sulfur. After centrifugation, we will decant the solution into a new test tube. We'll next add 6 molar ammonia to make the solution basic. We'll then add 2 to 3 drops of 1% dimethylglyoxime to test for the presence of nickel 2 ion. We will next centrifuge the mixture. The red precipitate confirms the presence of nickel 2 ion. We will next separate the iron and aluminum subgroups. The order of addition of the next 3 reagents is very important. We're first going to add 1 milliliter of deionized water and 1 milliliter of 6 molar sodium hydroxide to a 15 centimeter test tube labeled R12. We will next add 5 drops of 30% hydrogen peroxide to solution S10, which we had previously set aside. We'll then stir this mixture and add it to our 15 centimeter test tube with our water and sodium hydroxide mixture. We'll then mix this solution and let it stand for 1 minute. We will then heat this solution to decompose the hydrogen peroxide. After the hydrogen peroxide has decomposed, we will centrifuge the mixture. After centrifugation, this is what our mixture looks like. We will decant the solution into a new test tube labeled S12 for solution 12. Solution S12 will be set aside for analysis of aluminum and chromium ions. We will test the residue R12 for iron and manganese. We will now perform the test for iron 3 ion. To residue R12, we will add 1 milliliter of 6 molar hydrochloric acid and 2 drops of 3% hydrogen peroxide. We'll then stir the mixture and heat in a hot water bath. After the precipitate has completely dissolved, we will remove the solution from the heat and allow it to cool. After the solution has cooled, we will dilute it with 1 milliliter of deionized water, mix the solution well, and divide it into 2 equal portions. Portion number 1, we will continue with the test for iron 3 ion, and portion 2 we will set aside for the test for manganese 2 ion. To portion number 1, we will add 6 molar ammonia to neutralize the excess acid. We will then add 6 molar hydrochloric acid dropwise to make it slightly acidic again. We will next add up to 1 milliliter of 0.1 molar potassium thiocyanate to our solution, and a deep red color will confirm the presence of iron 3 ion. The deep red color indicates the presence of iron 3 ion. We will now perform the test for manganese 2 ion. We will take the second portion of our solution and place it in a hot water bath for 1 minute. After heating our solution for 1 minute, we will add a small amount of sodium bismuthate to our solution and stir for an additional minute. We will then centrifuge. After centrifugation, the dark purple precipitate confirms the presence of manganese 2 ion. We will now perform the test for aluminum ion. We will acidify solution S12 with the addition of 6 molar hydrochloric acid and add 5 drops in excess. We will then make the solution just basic with the addition of 6 molar ammonia. The flocculent precipitate indicates the presence of aluminum ion. We will now centrifuge our mixture. This is what our mixture looks like after centrifugation. We will then decant our solution into a new test tube labeled S13 for solution 13. We will set solution 13 aside for the chromium test. We've relabeled our residue with the aluminum flocculate as R13 for residue 13. We will now wash the residue with 10 drops of deionized water, centrifuge, and discard the wash liquid. We will now confirm the presence of aluminum ion. We will dissolve residue R13 in 1 milliliter of 6 molar hydrochloric acid. We will then add 2 drops of 0.1% aluminon reagent. We will then make the solution faintly basic with the dropwise addition of 6 molar ammonia. A red precipitate which flocculates confirms the presence of aluminum ion. The red flocculate confirms the presence of aluminum ion. We will now perform the test for chromate ion. We will add 1 molar acetic acid to solution S13 until it is slightly acidic. We will then add 5 to 10 drops of 0.1 molar lead acetate. A yellow precipitate of lead chromate confirms chromium ion. The yellow precipitate of lead chromate confirms the presence of chromium ion. Okay, students, that concludes our test for the hydrogen sulfide group in basic conditions, also known as the ammonium sulfide group or group 3. Thank you for joining me for this experiment.